Greetings again, this is Cantaloupe, and I'm here with a new video about something that is pretty handy for programming graphics, and that's the geo-sphere. You may have seen this in an application or two. It's not an ordinary sphere, it's a sphere where the points are all evenly distributed about the sphere, whereas with a conventional sphere you have rows and columns. It's like a globe looking thing, but geosphere is different. It's any number of points evenly distributed. I'm not sure how better to describe it, so I'm going to get right into the video and talk to you about how to create that. So while I'm coding this demo, I'm going to talk about curves, because I'm going to leverage a particular type of curve to create this shape. Now, the curve I'm describing isn't a visible curve. It's not something that you're going to graph directly. It's a curve, a mathematical curve that you're going to leverage to get the spacing that you're looking for in a geosphere. And again, that's you give it a number of points that you want to space evenly around a radius in 3 dimensions. That's what it is. So I'm creating this function, and what it's doing is it's starting with an empty array, and it adds points, random. They aren't even on a sphere when the function is called. The points are just not 0, they're randomized. So they aren't even aligned to a space or a radius or to each other or themselves. They're just not 0, and that's important. So the first thing that happens in this function is I define a loop, and this in the interest of performance, this loop is going to have to be as short as possible, because when you create one of these things, there's a bit of computation in the background to make everything work in the way that I'm doing it. So that can be time intensive if you have unnecessary steps or iterations in this loop. So each time I create this function, it comes out just a little bit different, but the effect is exactly the same. The final result looks exactly the same, and it functions the same. But the math is just a little bit different. The essence is you take that cloud of points that it created. The first thing it does is it makes this little cloud of points, which you can kind of see on the screen. And it has a nested loop. So you've got you start with 1 point, just whichever one happens to be first, and then you loop through all the other points, and it says, well, if the other point isn't myself, it checks to see that it's not going to be a 0 distance, right? If it's not myself, then move away from it. Just move an arbitrary distance away from it, divided by an exponent, a positive greater than 1 exponent. And what happens is any point that's further than that point, it becomes just a little bit less of a repelling force. And I don't know if I can explain this perfectly, but so the nearest point, you're going to be moving away from the most. I'm sorry. Yes, that's correct. So you move away from the nearest point the most, and then the one just a little bit further, you move away a little bit less and a little bit less. And the overall effect after you finish looping through all these points is they are a certain distance, obviously, from the center, wherever that is, and then you realign them. You truncate their distance from the center back to the size of the sphere that you're looking for, or 1 if you're going to multiply the size later, which is what I end up doing here. So I'm not sure if that makes sense. So you're moving each point away from the other points with a distance that's modified by the curve of an exponent. Now, this is a hugely powerful technique because curves, I use curves constantly. If you can visualize a curve, you can leverage it to achieve a lot of different things, a lot of different effects. So this is just one of them. And you see, I've already kind of done all this while I've explained it. So the geosphere is basically functioning now. It's doing what I just said. The points are evenly distributed, and right now I'm optimizing it because, like I said, you don't want any extra loops. So you want your exponent formula and your loop to be as efficient as possible, because maybe you want a huge number of points, and anything over like 500 points in one function call will take a few seconds with this function, unless you don't need precision. So there's an opportunity to code in some kind of quality of distribution kind of thing. I don't actually do that in this demo, but you could very easily say, okay, it's going to be a higher quality distribution. That is, they're going to be precisely even from each other, but it's going to take a much longer time to do that. And that this function will support that. But I can talk about that. If you have any questions, let me know. So after all that's done, I have some points, and they're fairly well distributed right now. You see on the screen that the geosphere's taken shape. The geosphere's done. So now what I'm doing, you see there's a red shape. What's that happen? Okay, so there's a fun little thing you can do once you've got your points distributed. You can then, in the same function that is creating this shape, loop through it right before you return the object, and maybe we want to return an optional second object, and that's what I'm doing now. I'm checking the minimum distance between any 2 points. So I'm just going to quickly loop through all the points and check which two happen to be closest. And I'm going to use that as a baseline. I'm going to say if any 2 points are about that close, 1.6 times that close or less is actually what I'm doing here, then add a line between them. Hey, why not? So now you have an actual, it looks like a polyhedron kind of, but it's not. It's just a group of lines. There are no faces on this thing. It's just lines between points, but it looks like a polyhedron. And then I'm doing some fine tuning right now. It's a balancing act between getting your spacing correct and the performance I was talking about, because the more even they are, the better the shape ends up looking, but the longer it takes to render it. So I'm kind of trying to find that balance right now, and is what I'm doing in the code. So it's basically done. That's the essence of it. The shape and the geosphere is completed, and it will accept any number of points via the function, and you can do that. So thank you very much. I hope that was interesting. Let me know if you have questions. Have a good day.